toys get friendly.
And math becomes less scary and way more fun.
This is My Mothers. I am Rosell.
I am Mylien.
I am Hans.
And Mikay. Where we break down math one step at a time.
Mind Matters. Solving systems of linear equations using augmented matrix. What is an augmented matrix?
An augmented matrix is a compact and organized way to represent a system of linear equations. Instead of writing out all the variables and equal signs, we put just the coefficients and constant into a matrix form. It's like turning a wordy paragraph into a neat table. This method is especially helpful in solving large systems of equations. It saves time, reduces errors, and sets us up perfectly for techniques like Gaussian elimination or row operations.
Let's have an example. First, let's convert it into augmented matrix form. We call the vertical part as the column part dot and the horizontal part as the row part. Now that we already have the augmented form, our next goal is to turn these numbers into 0 dot and these numbers into positive 1. Now let's perform the row operations. Let us turn the number 2 into 0 first dot, next the number 1, and last is the negative 2. Our operation would be negative 2 R1 plus R2 is the new R2. Now you will have to multiply all the numbers in row 1 to negative 2 and add the results to the numbers in the row 2 for you to get the new row 2. And this is now the result. Now let's move on and turn number 1 into 0, and for our new operation it would be negative R1 plus R3 is the new R3. Now you will have to multiply all the numbers in row 1 to negative and add the results to the numbers in the row 3 for you to get the new row 3. And this is now the result. The only numbers that will be changed are the numbers in the row 3. Now let's turn the number negative 3 into 0, and for our new operation it would be negative R2 plus R3 is the new R3. Now you will have to multiply all the numbers in row 2 to negative and add the results to the numbers in the row 3 for you to get the new row 3. And this is now the result. The only numbers that will be changed are the numbers in the row 3. Now that we already turned all those numbers to 0, let us now move on in turning the numbers 1, negative 3, and negative 1 into positive 1. Now you will have to multiply all the numbers in row 2 to negative 1/3 for you to get the new row 2. And this is now the result. The only numbers that will be changed are the numbers in the row 2. Now let's turn the negative 1 into positive 1, and the new operation would be negative R3 is the new R3. You will have to multiply all the numbers in the row 3 to negative for you to get the new row 3. And this is now the result. You already completed the process from turning numbers to 0 and positive 1. Now we can see that our z is equals to negative 6, and we will now move on to substitution for us to get the value of the other variables x and y. To get the value of y, we will solve the equation y plus 1/3 z equals to 3, and we will substitute the value of z to negative 6, and the result would be y is equals to 5. Now let's solve for the value of x. Let's use the equation x plus y plus z is equals to 6 and substitute the value of y to 5 and value of z to negative 6, and the result is the value of x would be 7. Now the value of x is 7, the value of y is 5, and the value of z is negative 6. You can verify it by doing the checking.
I went to a school supply store on 3 different days and bought various combinations of items. On first day, I bought 1 notebook, 2 pens, and 3 pencil for 105 pesos. On the second day, I bought 2 notebooks, 3 pens, and 1 pencil for 120 pesos. On the third day, I bought 3 notebooks, 1 pen, and 2 pencils for 130 pesos. I am curious to know the individual prices of each item I bought. Will you help me find out?
Let's follow the process earlier.
Thank you so much for helping me.